So in our numerical modeling, we have done 3D solid element for all the parts. We already have modeled the soil, the steel, the concrete. Soil have been modeled as linear, elastically, perfectly plastic material, considering more column. We have done also sensitivity analysis to see the effect of the size of the meshing. We have installed our boundary conditions 3 to 5 meters from the tap here and 10 to 20 meters from the center of the pipe. In order to make verification for our model, we adopted some cases presented by NREL for their 5 megawatt wind turbine. They suggested that would be 6 meter diameter by 36 meter length. So we have done the same case under wind load and wave load to see the mud level displacement here. In the analysis, it was between 1.5 to 2 centimeter, and in our analysis, it was 1.65 centimeters. The displacement at mud level. So we have good agreement, so we have good confidence in our model. So after we got the wind tunnel loads, wave loads, we need to start our barometric study to see the performance of the system. We have studied the mean sea level lateral displacement for different foundation system, for monopile diameter 4 meter, monopile diameter 6 meter, hybrid system with blade diameter 12 meter, hybrid system with blade diameter 16 meter, and hybrid system with blade diameter 12 meter with reps. We have studied under just 2 components, 3 components, and also 6 components. All these tests have been done at main sea level for lateral displacement and the maximum wind load coming from the wind tunnel and the wave loads. You can see here, this is the main sea level. We can see here, this is the red one representing the monopile, where there is the larger displacement, lateral displacement, because it's not supposed to resist this larger load because it's already represented for 2.3 megawatt wind turbine, not 5 megawatt wind turbine. We can see generally the effect of the reps decrease with the increasing of the pile length. We can see here also relation between the main 2 systems, which will be the hybrid system with blade equal to 16 and the monopile with diameter to 6 meters. We can see this is the monopile diameter 6 meter, and this is the hybrid system with blade diameter 16 meter and pile diameter 4 meter. We can see that the hybrid system is better than the monopile till 80 meter. Then after that, the lateral displacement of the monopile 6 meter will be less than the hybrid foundation system. But with adding 3 components, we can see here that the hybrid foundation system will be less displacement than the monopile 6 meter till 24 meter. And we can see that all displacement here is larger than displacement here. So we should use 3 or 6 components rather than just 2 components in our analysis. We can see here also that the hybrid foundation system will be better than the monopile till 23 meters. We study also lateral displacement at mud level for the different foundation system under 2 components, 3 components, 6 components. As we said, at mud level, maximum wind load and also the wave loads. We can see here, this is the mud level. We can see that also the monopile has larger displacement, but we can see here that the relation between the monopile with diameter 6 meter and the hybrid system with diameter 4 meter. We can see that the hybrid system is better than the monopile till 24 meter length. But after adding the different components, we can see that the hybrid foundation system is better than the monopile with 6 meter. So our hybrid foundation system with diameter of the pile 4 meter is better than the monopile diameter with diameter 6 meters. We can see here, this is the displacement here. We also calculated the pile head rotation at mud level for the different system, also under different load combination to see the maximum pile head rotation. And this is one of the characteristic of DNV, that the pile head rotation not exceed 0.5 degrees. We have done also vertical capacity analysis. This is for different foundation system. We can see vertical displacement and the load here for different foundation system. Starting with hybrid system with no reps, diameter equal to 16. Hybrid system with reps, and hybrid system with no reps, diameter equal to 12. With pile diameter equal to 6, with pile diameter equal to 24, with different lengths 16, 24, and 36. We already calculated the monopile capacity of 4 meter diameter pile, and we make it as a reference pile to see the effect of adding different systems. So for hybrid foundations, so for the monopile with diameter 6 meter compared to the monopile with diameter 4 meter, we can see 20 to 42% increase in capacity. While adding the plate, we can see 500% increase in capacity due to the effect of the plate. And we can see here that this effect is reduced with the increase of pile length due to the effect of the pile friction. After this several cases analysis by Abacus model, we'll be able to present this equation as a Bernoulli estimation for the vertical capacity of hybrid foundation system, and we can see here this relation between capacity of monopile and capacity of plate depending on the relation between plate diameter and pile length. So at the beginning, for any designer, he'll be able to use this equation to know the capacity of the vertical capacity of this hybrid foundation system. From Abacus models, we can see here the stresses, the vertical stresses in case of the pile and in case of the hybrid foundation system to see the effect of adding the plate in increasing the vertical capacity in the soil. We can see this effect here. We have done also lateral capacity test as displacement control. For different foundation system, we have horizontal displacement to lateral displacement for different foundation system. As we said, pile diameter 6 meter, hybrid system with no reps, diameter 60 meter, hybrid system with reps, hybrid system with no reps, diameter 12 meter, and the pile with diameter 4 meter. And we compared them with the pile capacity of just monopile diameter 4 meter to see the increase in lateral capacity. And we can see it's less than the previous one for the vertical capacity. And we can see that using monopile increased lateral capacity by 38% to 113%. And we can see that the lateral capacity of the monopile diameter 6 meter is larger, increased the capacity larger than the hybrid foundation system, but the difference is less than 10%. And also by adding the vertical component, we can change these values. After we already have done our wind tunnel test, we already got the wave loads applied in our numerical load, model. We studied the behavior of different components, the behavior of different hybrid systems. We'll be able to use 1G scale down test. So what's the 1G scale down test? 1G scale down test is geometrical scaling of the model itself, but not the soil under gravity. So it will be studied under just 1G. So we'll see how we are modeling or scaling down the soil here. Why we are doing 1G scale down test? To be able to overcome some limitation in modeling some huge foundation system in centrifugal test, especially offshore structures, and also studying long-term cases effect in which cannot be studied in numerical analysis by Abacus, as in static cases in Abacus it take up to 3 days. So in under dynamic load it will take larger time. Also a model verification, we have done model verification in our analysis here. In our test we depended on major two things, LeBlanc 2008 and Hell-Magic 2012. And in LeBlanc 2008 we also have provided monopile to resist load from wind turbine, but he used typical loads. And he used the wire pulley technique for static load and the motor from AC for cyclic loading. For Hell-Magic, he used the device Instron to be applied cyclic loading on his pile. So LeBlanc 2010, he represented equation for relation between the moment and the load as interaction diagram. So he represented this equation here where we will be able to get relation between the moment and horizontal load for any pile under horizontal vertical moment. He models the soil by relation between vertical stress and phi and relative density for any soil. So by knowing the vertical stresses here, overburdening stresses and the field, phi and relative density, and overburdening stresses in the lab, and phi. So I need to have relative density in the lab to be able to scale down the soil. After making this scaling down, I'll have non-dimensional parameters for moment, vertical force, horizontal force, rotational degree, load eccentricity, aspect ratio. So how we are going to use this non-dimensional parameters? So by knowing the moment on the field or prototype, diameter of the pile, prototype, length of pile in prototype, the diameter of the pile in the model, length of the pile of the model depending on my geometrical scaling and my boundary condition, I'll be able to get the moment in the model. So applying the same thing for vertical load, horizontal load, theta and E, and aspect ratio. So in his analysis, he just depended for just monopile. So we need to add the effect of the blade to the work to see how it's going to change things. The main thing in this system, it needs to be rigid, to be able to scale it down. We have done our test here in structural lab with using Ottawa Sand F50. This is our steel tank here. And this is our model, one of the models. In this case, it should be hybrid system. We can see the plate here is steel, not concrete, because we want the system to be just rigid. We can see this is LVDT, and this is the actuator here to apply the load. In our barometric study, we use pile diameter 80 millimeter, 120 millimeter to represent 4 meter, 6 meter diameter, and also blade diameter 320 millimeter to represent 60 meter, and 450 millimeter to represent 22 meter. The wall thickness was 5 meter, penetration depth was 720 millimeter to represent 36 meter pile penetration. Load eccentricity we have done for static load, we have done 1 meter eccentricity, 0.75 meter eccentricity, 0.5 meter eccentricity. As you can see here, this is the wire, this is the volley, this is the load to be able to add load during static testing. This is cross section of our model, which would be the steel tank with diameter 1.35 with depth 1.5.